Welcome to March 27th LeetCode Challenge, the K weakest row in a matrix. You're given an m by n binary matrix mat of 1s representing soldiers and 0s representing civilians. The soldiers are positioned in front of the civilians. That is, all the 1s will appear on the left of all the 0s in each row. A row I is weaker than row J if one of the following is true. The number of soldiers in a row I is less than the number of soldiers in row J. Both rows have the same number of soldiers and I is less than J. Return the indices of the K weakest rows in the matrix order from the weakest to strongest. So we're given a binary matrix, right, of basically 1s and 0s, and we want to be able to find the row such that it has the least number of 1s. I is less than the number of soldiers, J. And then both the rows have the same number of soldiers, and I is less than J. So we want to be able to return the weakest row. Order from the weakest to the strongest. Alright, so we're given this matrix here, and we're given K. So K is integer defining by the let's see, indices of K weakest row. So we want to be able to find 3 of the weakest rows in the following order. So we find that row number 2, 0, and 3 is the weakest, going from weakest to strongest. So how is that possible? So look at row number 1, row number 0. Row number 0 has 2 soldiers and 3 civilians. Alright, row number 4, number 2 has 4 soldiers, row number 1 has 1 soldier, row number 2 has 1 soldier, row number 3 has 2 soldiers, row number 4 has 5 soldiers. So you want to find the one with the least amount of soldiers from the weakest to the strongest. So we're given 3, so we have basically 2, we have the index 0, so the next row 2 has 1 soldier, so it's the weakest, followed by 2 soldiers in row 0 and 2 soldiers in row 3. So that's pretty much it. So likewise, similarly, we want to find the weakest soldiers, weakest row, and then we're given basically all of them have 1 soldiers except for the second one, row 1. So we just basically return the any of the 2 except for 1, right? So basically given 0, 2, and 3. Right? And we just return it in the following order. So notice how it goes from the 0 and 2. It doesn't capture 3. 3 should still be correct, but we want it in that order. So the length of the matrix is m. The length of the matrix is index I, so which is the column, is index n. M and n is between 2 to 100. K is between 1 to m. The length of the size of the matrix I and J is either, so each cell in the matrix is either 0 or 1. Alright, so that was a wordy explanation, but it's a pretty easy one. So the simplest way to solve this problem is to calculate the sum of every matrix row. We're going to add it all together and count the sum of each row. And I'm going to sort the results by the sum and cut off the first K value. So basically count the number of each row, sort it, and then just count the first K amounts. Then we can calculate the sums and we form a new list in order not to lose information about the row indices. Then we use a tuple as well to return those indices. So the first thing we do is let's do sums equal to an empty list there. So this is going to keep track of stuff. So for row I and row, for each index and row, we're going to enumerate the matrix mat, and then we're going to append it, sums.append to our list. What we're going to append the sum of each row which is going to be a tuple actually, the sum of each row and index I. So basically, we take the sum of each row, and then we store the sum of each row, and we store the index of each row inside tuple inside sums. So we don't lose track of our indices and the sum of each row. Then we're going to sort it out. So let's call this sorted nums, and it's going to be sorted sums. Alright, we just sort it, and then once we sort it, we want to cut off the k amount. So the k weakest rows, call this k rows, I guess, and that's going to be sorted sums, and we're going to take that at the slice of k, from the beginning till k, I should say. And then once we have all that sorted out, as everything is sorted, cut off k amounts, next we're going to do is return the results and the indices. So we have our, basically we have information already there, we just need to get this element. So we're going to have the output being returned in a list, and then for each value in k rows, we are going to append the output of each index, so the value of the second element or the indice 1 in the tuple to our array. Return the output. So this is basically a brute force approach, cycling through each element, taking a sum, putting an index in a tuple, sorting it, taking the k slice, then putting it back into an array. That's pretty much it. Let's submit it and see how it goes. So this sorting algorithm is basically a big O of n log n times, which is decent. Space complexity is also sorting as well, which is the highest, is big O of n. Alright, and that's it. Have a great day, guys.